Now let us move to the next illustration, and through next illustration we are going to learn the concept of angular impulse, first point. Second point, we will cover the application of the impulse momentum equation in the rotational dynamics, and third point we will cover here concept of rolling, and fourth point we will cover again the application of the torque equation, right. So let us move to the illustration. Here in this figure you can observe here this is the solid ball, and this AB is a horizontal diameter, right, and mass of the ball is 0.4 kg, radius 10 centimeter, and at time t equal to 0 a sharp impulse J is applied at point B at angle 45 degree with the horizontal, and just after application of the impulse the ball start moving with the velocity 10 meter per second, that is in the leftward direction. The first point we need to calculate the impulse J, we need to calculate the value of J, and it is given the coefficient of the kinetic friction between the floor and ball is 0.1, then we need to find the velocity of the ball when it stops sliding, that is at the time of rolling, and the third point we need to calculate the time up to this instant, that means we need to find the time from t equal to 0 to the instant when the ball start rolling, that means sliding stops. So let us do one thing, let us place the diagram to the next page first, and we need to use G equal to 10 meter per second square. This is the first part of the question we are going to analyze. So this is the situation, right. We can make the horizontal and vertical component of the impulse. Horizontal component say Jx, Jx is equal to J cos 45 and Jy equal to J sin 45. This is J cos 45, that is J divided by root 2, and vertical is also J divided by root 2, and it is given after collision ball start moving with the velocity v naught. So this is the v naught, right. And we know this horizontal component, because ball is at rest initially and it start moving in the leftward direction with the velocity v naught, that means the horizontal component of the impulse is responsible for providing the linear momentum in the horizontal direction. That means we can find the value of J by equating this equation J cos 45 equal to mass of the ball multiplied by v naught, right. So this is the horizontal impulse, that is J cos 45 equal to mv naught. From this we can find the value of J, and J after calculation we will calculate this value J equal to 4 root 2 kg meter per second. This is the impulse acting on the ball, right. So let us do one thing, let us write this impulse value to the next page, this one. Now let us move to the next part of the question, that is the velocity of the ball when it stops sliding and time. For calculating this value we need to find the acceleration of the ball and angular acceleration of the ball, both things we need to calculate, right. So let us find the vertical component of the impulse first, analyze the vertical component of the impulse. We can observe here this vertical component is responsible for providing the angular momentum, because this component, that is the horizontal component, will pass through the center, that means it is not responsible for providing the angular momentum. This component, the vertical component, is responsible for providing the angular momentum, right. And the initial angular momentum of the ball, let us find the initial angular momentum. We can observe here the angular impulse about the center of the ball, that is J sin 45 multiplied by r, and let the angular velocity of the ball just after providing the impulse is omega naught. So we can write J multiplied by cos J sin 45 multiplied by r equal to I multiplied by omega naught, right. So this is the impulse equation for the angular motion, that is J r sin 45 equal to I omega naught, right. And we are given the radius of the ball, mass of the ball, That means we can find the value of I, that is the moment of inertia of the ball about the axis passing through the center of mass of the ball, that is about the centroidal axis. So this is equal to, because it is a solid ball, this I equal to 2 by 5 mr square. M equal to 0.4, R equal to 10 centimeter. So this is equal to 2 by 5, 0.4 into 0.1 whole square. And if we calculate this value, this is equal to 1.6 into 10 to the power minus 3 kg meter square power minus 2. This one. Okay, we got the moment of inertia. So let us write the moment of inertia of the ball here. Okay. Now we got the moment of inertia, we know the value of the impulse. Now we can find the value of the omega naught. We have this equation. Here we know the value of J, we know the value of I, and we know the value of radius also. So let us substitute this value in this equation. This is equal to 4 root 2 multiplication 10 centimeter, that is 0.1, sine 45 1 by root 2, and value of I equal to 1.6 into 10 to the power minus 3 kg per meter square. So this is omega naught, that is 250 radian per second, and sense of rotation is clockwise, because we can observe here about center of mass, about the centroidal axis, this impulse will provide the clockwise rotation. So angular velocity, that is the initial angular velocity, is 250 radian per second in the clockwise sense. Now let us calculate the acceleration of the ball. For calculating the acceleration, we need to draw the free body diagram. So let us draw the free body diagram here. This is the sense of rotation clockwise, and omega naught equal to 250 radian per second. So let us make the free body diagram. You know, mg will act in the downward direction, normal direction upward direction, and sense of rotation is the clockwise. That means this surface is moving in the left direction. The friction force will act, that is the sliding of nature, in the rightward direction, that is mu multiplied by n. Right? We can observe here the sense of rotation is the clockwise, and this mu multiplied by n provide the external torque in the anti-clockwise sense. That means the angular acceleration of the ball will be anti-clockwise sense, that is alpha, like this. Okay. So now we can calculate the value of A. We can write this acceleration, that is equal to A. Suppose this acceleration is A, that is mu multiplied by n equal to ma. This is the force equation, the horizontal direction. So in the horizontal direction, we can write mu n equal to ma. Right? We can substitute the value of mu is given as 0.1, and this is the mass m. M is here is the 0.4 and g equal to 10. So n equal to 0.4 multiplied by 10. Here 0.4 will get cancelled, and this is equal to acceleration, and this is 1 meter per second square. So here we got the value of the translational acceleration of the ball. In fact, it will retard the linear velocity of the center of mass of the ball. Now let us move to calculate this value alpha, that is the angular acceleration. For calculating the angular acceleration, we need to use the torque equation, and we can apply the torque equation only about the centroidal axis, because we don't have any instantaneous axis of rotation in this situation, because ball is sliding. So let us move to calculate the value of alpha. And for calculating alpha, we need to apply the torque equation about O. That means mg and normal reaction will not provide any torque, and torque of mu multiplied by n should be equal to mu n multiplied by r in the anti-clockwise sense, that should be equal to I alpha. I is the moment of inertia about the centroidal axis. We know the value of mu, we know the value of n, r. So we can write here this mu equal to 0.1, n equal to mg, that is 0.4 multiplied by 10, and r equal to 10 centimeter, and I we have calculated this value. So we can substitute the value, and here we can calculate alpha equal to, after calculation it will be 25 radian per second square, and sense of rotation is the anti-clockwise. So, this is the angular acceleration. Actually, it will retard the angular velocity, right? Now, what will happen? The velocity of the ball, that the linear velocity of the ball will decrease, also angular velocity of the ball will decrease. At certain time, you can observe here, if we consider this point, the linear velocity in the leftward direction and angular velocity should be in the rightward direction for making this point as no sliding point. But initially it is rotating in the clockwise sense. That means the sense of motion due to rotation is in the leftward direction. That's why it is sliding. That means this angular acceleration will do one thing. First, it will reduce its angular velocity to the 0 value, and it finally change the sense of rotation from clockwise to anti-clockwise, so that the point of contact has no sliding tendency. Let us assume the sliding continue for the time t. That means rolling start at time t. This is the value of alpha and this is value of v. This is the velocity when rolling start, right? So, let us assume this time as t time. This at this time, because the action started at t equal to 0. So, at this time the rolling start. That means we need to calculate the instantaneous velocity at any time. We know the acceleration, we know the initial velocity. So, here we can write v equal to u plus at, that is v equal to v naught minus at. So, we can write the equation of the kinematics and we can substitute the value of v naught, a and t is unknown. So, this is the value. This is the velocity of the center of mass of ball at time t. Now, let us find the angular velocity. We know initial sense of rotation was clockwise. Let us take clockwise sense as negative, anti-clockwise direction as positive. So, we can write omega equal to omega naught plus alpha t, and omega is not is negative and alpha is positive because it is an anti-clockwise sense. So, we can apply this equation for calculating the angular velocity. We can substitute, this is minus 250 and this alpha is 25. So, this is the angular velocity at any time, right? And when rolling will stop, this velocity, that is the velocity of the center of mass, that should be equal to r alpha, right? This is the condition for no sliding of the point of contact. So, we can write when sliding stops v equal to r alpha. We know the value of v at any time, we know the value of omega, r is given, that is 10 centimeter, we can substitute the respective value. We can find the value of t after calculation, this value is 10 second. If we calculate, it will be 10 second. If we substitute the value of v in this equation, this is 10 minus 10, that is equal to 0. That means this ball will stop at t equal to 10 second. That means when sliding stop, that means it is not going to roll. Sliding will stop at t equal to 0 and that time ball will also stop. It will start translating as well as rotating, because if we substitute t equal to 10 second, this angular velocity is also going to be 0. So, that ball will be at rest at t equal to 10 second. So, sliding will stop at t equal to 10 second, ball will also be at rest at t equal to 10 second. So, required time is 10 second and velocity required is 0. This is the situation. Okay.